It came from the darkness between the stars. At first glance, the third interstellar object looked like a comet, but then it started breaking the rules. Its tail pointed toward our solar star. It released nickel without iron. It carried chemistry that shouldn't exist. And with each observation, one truth became harder to ignore. This object didn't fit. Not in models, not in categories, not even in our understanding of what nature allows.
The chance of all of these anomalies coming together is 1 in 10 to the power 16. Like each of them has a percent level or less than a percent likelihood, and there are 8 of them. It's really a small probability that we will see all of these anomalies.
Atlas isn't just another interstellar visitor. It's a rupture, a contradiction that's forcing science to rewrite its foundations. Because once you've seen something impossible, you can't pretend the rules still hold. This is how Atlas changed science forever. The discovery that changed everything. In July 2025, telescopes across the southern hemisphere caught a strange movement in the sky, a slow drift from the direction of the galactic center. It wasn't fast enough to dismiss, nor faint enough to ignore. What they had detected was real, and it was coming straight through our solar system. At first, it seemed familiar, a distant point with a faint coma, the kind of thing astronomers might catalog and forget, but the trajectory was wrong. Hyperbolic, retrograde, not spinning around our solar star like a planet-bound object, but cutting through the solar plane at a shallow, deliberate angle, just 5 degrees off the ecliptic, almost as if it knew the path we travel. They called it Atlas, the third confirmed object to visit us from interstellar space. Before it came Oumuamua in 2017, which accelerated in ways no natural body should. Then Borisov in 2019, a comet more familiar in appearance, but chemically foreign. Both raised questions. Both disappeared before we could answer them. But Atlas was different. Larger, brighter, slower, and above all, more accessible. For the first time, we had time. Time to look, measure, follow. From the beginning, things didn't make sense. Its coma was brighter than expected for an object of its size. Its tail wasn't trailing behind, it was facing forward, toward our solar star. The dust particles it released didn't behave like dust. They resisted solar radiation, they drifted in ways that defied our models of how cometary material should move. Some scientists suggested larger grains. Others proposed exotic surface structures. None of the answers were satisfactory. And then came the orbit. Atlas wasn't just passing through, it was weaving through. First Venus, then Mars, then Jupiter, a planetary sequence so precise it forced a statistical reassessment. Avi Loeb, Harvard astrophysicist, estimated the chances of such a path occurring by chance at about 1 in 20,000. This doesn't prove intention, but it demands attention. For many, Atlas was simply a relic, a frozen fragment from a dying stellar system, hurled into the void long before Earth even formed. But for others, it became something more, a puzzle too deliberate to ignore, a visitor with questions written in its very chemistry. And the deeper scientists looked, the stranger the answers became. Because Atlas wasn't behaving like a comet, it was behaving like a contradiction. And that's where the real mystery began. The impossible chemistry. It started with a glow, spectral lines that didn't belong. When scientists pointed the James Webb Space Telescope and Hubble at Atlas, they expected the usual suspects. Water vapor, carbon compounds, traces of silicates, maybe some iron, perhaps some organic dust. What they found was something far stranger. The object was emitting nickel. Not trace amounts, not hints or possibilities, but full measurable streams, about 4 grams every second. That alone would have raised eyebrows. But what came next fractured the foundation of cometary chemistry. There was no iron, not a little, none. In every known comet, iron and nickel are paired, born together in the hearts of ancient stars, bound in the mineral structures of planetary debris. They sublimate together when exposed to heat, but Atlas had decoupled them. Nickel was escaping freely while iron remained silent. And this wasn't just atomic nickel. It was something more refined. Among the emissions, scientists identified nickel tetracarbonyl, a compound known on Earth almost exclusively from metallurgical industries and aerospace applications. A molecule so unstable it rarely forms in natural environments and never, until now, in deep space. This was more than an anomaly. It was a violation. Some suggested an exotic formation scenario. Perhaps Atlas was born in a region of its home system with unique temperature gradients, where iron condensed into core minerals while nickel remained volatile. Others proposed a long history of radiation exposure, centuries of cosmic bombardment selectively altering its outer layers. But none of these theories could fully explain the presence of an industrial compound drifting in space. And none could explain what the object was doing with carbon dioxide, because alongside the metallic signature, Atlas was venting gas CO2 in volumes that exceeded its water vapor production. The ratio was striking: 8 parts CO, 2 to every part H2O. This kind of chemical profile doesn't match anything in our database of known comets. It doesn't align with any solar system chemistry we've cataloged. It points to a place of origin far beyond our understanding. Somewhere cold, violent, alien, and then came the light. Polarization readings showed dust grains scattering in patterns never seen before. Negative polarization, something typically associated with surface textures unlike anything we've encountered, as if the grains themselves were shaped differently or built differently. Together, these details began to paint a picture, not of a comet, but of something more. A body shaped by rules we don't yet understand. A chemistry that suggests either a natural process we never imagined or something we didn't expect to find. Atlas didn't just break models, it broke the comfort of knowing where nature ends and the unknown begins. Science confronts the impossible. Science was never meant to be comfortable. It begins in wonder, but advances through contradiction. We build models not to lock in truth, but to test it, push them until they break. And when they break, we face a choice: ignore the fracture or follow it deeper. With Atlas, the fracture is no longer theoretical. What began as a comet-like object with a strange trajectory quickly transformed into a challenge to every expectation we've ever held about how small bodies behave, how chemistry unfolds in space, and how interstellar matter should look when it crosses our cosmic threshold. The first cracks appeared in the dust and gas it released. Nickel without iron, carbon dioxide in abundance, organic compounds that seemed more preserved than anything we've seen near our solar star. But these were just data points. And science is good with data points. It bends, reshapes, evolves. Theories were proposed. Some suggested that in the alien nursery where Atlas was born, the chemistry of planetary leftovers followed a different path. One where volatile nickel compounds formed and iron got trapped in the core. Others pointed to selective radiation damage over eons in deep space. This could explain the chemical imbalance, if not the presence of nickel tetracarbonyl, an industrial molecule known on Earth. Individually, the anomalies could be rationalized. But together they began to resist assimilation. Then came the orbit. Retrograde, shallow, a trajectory that didn't plunge from above or below, but slid almost along the plane of our solar system, 5 degrees off the ecliptic. That alone is rare, but the path it took passing by Mars, Venus, then Jupiter was even more disturbing. Avi Loeb, Harvard astrophysicist and perennial scientific provocateur, calculated that such a flight path had about a 1-inch, 20,000 probability of occurring by chance. The sequence wasn't just curious, it seemed precise. Now, precision doesn't prove intention, but it raises the bar. It invites the question every cautious scientist dreads: what if this isn't random? What if it's something more? Most in the scientific community remain grounded, reluctant to leap to artificial explanations, and rightfully so. The universe is vast. The strange is often just the unfamiliar, waiting to be understood. But something about Atlas has changed the tone of the conversation. The resistance to alternative ideas isn't as fierce as it was with Oumuamua. There's more humility now, a recognition that interstellar objects may not follow our rules, that our rules, in fact, may be far too narrow. We've confirmed only 3 visitors from beyond our system. Oumuamua in 2017, Borisov in 2019, and now Atlas. Each stranger than the last. Each introducing questions our models weren't prepared to answer. We can no longer assume that all interstellar objects are simply frozen leftovers from other solar systems. They're not consistent, they're not predictable, and increasingly, they're not explainable. This realization is reshaping more than our theories. It's reshaping our attitude toward the cosmos, where once we looked outward with the comfort of extrapolation, assuming other systems would echo our own, we now face the possibility that we are the outlier, that other regions of the galaxy may produce matter, motion, and behavior completely foreign to our understanding. This kind of paradigm shift is rare, but it's not without precedent. In the past, we learned to let go of Earth as the center of the universe. We learned that time bends, that space stretches, that particles disappear and reappear without cause. Each time, science didn't collapse. It adapted, grew, and now Atlas may be demanding that growth again. Whether natural or not, alien or common, Atlas isn't the anomaly. It's the revelation that our models were always incomplete and that the universe is still writing chapters we haven't learned to read yet. And that's the most important discovery of all, the window closing. The most frustrating thing about discoveries like Atlas is that they don't wait for us. They move on, undisturbed by our questions, unmoved by our curiosity. And now, as it approaches our solar star, Atlas is sliding from view, just when things were getting interesting. Its perihelion brings both potential and loss. As the heat intensifies, deeper layers of volatile material may awaken. Jets could erupt. Surface structures might crack, revealing secrets locked away since before our solar star even formed. But for a critical period of time, we'll see none of it. The solar glare will blind our best telescopes. Hubble can't track it. Webb must look away. The most important phase of its behavior may unfold in silence, unobserved, undocumented, unresolved. There are options. JUICE and Psyche spacecraft already in transit through the inner solar system will pass within observational range. But they weren't built for this. Their sensors aren't calibrated for comets, and their missions aren't designed to pivot. Still, some scientists are pushing for reprogrammed maneuvers, small course corrections that could capture something, anything. And then there's Juno, orbiting Jupiter with dwindling fuel and a damaged main engine. Juno has been suggested as a long-shot candidate for an intercept. The idea is ambitious, risky, perhaps impossible, but it shows how seriously the scientific community is beginning to take this object. Atlas may never return, and letting it disappear without trying to meet it halfway seems almost irresponsible. Because this isn't just a rock from another system, it's a question one we may not get to ask again. If we miss this chance, if no images are captured, no close passes attempted, we'll be left with only the data we've already collected. Enough to suggest, not enough to explain. And that's what makes this moment so difficult. Not the mystery, but the fact that it may pass unanswered. And long after it's gone, drifting alone in the darkness, the debate will continue. Scientists will argue about its nature, its chemistry, its path, but the object itself will have departed. And with it, the best chance we've ever had to learn what it really was. Because even in science, some doors close forever.